Hello everyone. Today I am going to discuss about the next step of water treatment is disinfection. Let us start. The filtered water may normally contain some harmful disease producing bacteria in water. These bacteria must be killed in order to make the water safe for the drinking purpose. This process of killing the bacteria is known as disinfection or the sterilization. Means whenever we kill the microorganism or the microbacteria present in a water, that step is called the disinfection. Now the disinfection kinetics. When a single unit of microorganism is exposed to a single unit of disinfectant, the reduction in microorganism follow the first order reaction. You know that the first order reaction means it depend on the uh, concentration of one reactant. Means whenever there is the total reaction or the total impurity in terms of water is present or which is depend on just the presence of one microorganism, so it is called the first order reaction. Means whenever there is the impurity present depend on microorganism along with other quantity or other ingredient present in water, which makes the water becomes a disinfectant, are called the second order third order reaction. But whenever the only microorganism is the reason of disinfection of water, so that it is called the first order kinetic or the first order reaction. Now the equation of first order reaction is the dN by dt is equal to minus Kn, or you may call that the N is equal to N naught e raised to minus Kt. This equation is also known as the Chick's law, where in this law the capital N is the number of microorganisms present in a water, or small n naught n naught is the initial number of microorganisms present in water. K is the disinfection constant, T is the time, or it is called the constant time. This is the equation. Now the methods of disinfection. The first method is the boiling. The bacteria present in a water can be destroyed by a boiling for a long time. However, it is not practically possible to boil the huge amount of water. So, the moreover it cannot take care of future possible contaminations. Means whenever there is just water used for the drinking purpose, then that water is allow or water is easy for the this undergoes this process. But whenever the large amount of water is considered, then it is not possible to boil that amount of water. This is the first method of to remove the disinfection present in a water. Now the next is the treatment with excess of lime. Lime is used in a water treatment plant for softening. Lime means a soda lime or NaOH, sodium hydroxide. It is also called a lime. Now, but if the excess lime is added to the water, it can in addition kill the bacteria also. The lime when added raise the pH value of water, making it extremely alkaline. Means whenever lime means a soda lime like NaOH is or the other process are chemicals are used for the soda lime process. Soda lime process is called the water softening process, in which NaOH is used for the water softening. But whenever this NaOH means a hydroxide, and hydroxide is the having a pH greater than 7, means whenever we add that hydroxide or the soda lime in a water, then the pH of that water get increased, so that water becomes alkaline. So it have a tendency to kill the bacteria present in a water sample. This extremely alkaline has been found detrimental to the survival of bacteria. This method needs the removal of excess lime from the water before it can be supplied to the general public. We know that the drinking purpose of water need to 6 to 7 pH or is permissible, but whenever the pH is increased, then it is dangerous for us. So that uh, before that water is supplied, then the removal of excess of lime is necessary. So that the treatment like recarbonation for the lime removal should be used for this after the disinfection process. This is the second process, is the treatment with excess of lime. The next method is the treatment with ozone. The ozone readily breaks down into the normal oxygen, and we know that the ozone chemical formula for that ozone is the O3. Whenever any salt present in a water, or the any salt like a chlorine present in air also break that the O3 bond, and then it converted into a OCl and O2 radicals. Whenever that O2 is again reacted with another Cl1, then again that O2 chain get break and then again converted into a nascent oxygen. So that nascent oxygen is a powerful oxidizing agent and remove the oxygen, organic matter as well as bacteria from this water. So this treatment of ozone is very important to remove the disinfection present in water. Now the next process is the chlorination. We all know that, or we are the familiar about this process. The germicidal action of chlorine is explained by the recent theory of enzymatic hypothesis, according to which the chlorine entered in the cell wall of the bacteria and killed the enzyme which are essential for the metabolic process of living organism. Means that chlorine is very hazardous, or it is the main essential ingredient that kill the bacteria by enter in a cell wall of that bacteria, and it block the metabolic process of living organism, so that it get dead or it becomes reduced. So this chlorination process is important for removal of disinfection. Now let us see about the chlorine chemistry, or how that chlorine is useful for the removal of disinfection. When the chlorine is added to the water supply in two ways, it is the most often added as a gas. Means we know that the chlorine is a gas, its formula is the Cl2. However, it also can be added as a salt, such as the sodium hydroxide. Means not the chlorine gas is not directly used. Whenever we are required that chlorine molecule for the disinfection process, so the chlorine is used with along with the sodium hydroxide or sodium hypochlorite. We know that the formula for the sodium hypochlorite is the NaOCl. It is also called the bleach or the bleaching powder. Chlorine gas dissolved in a water flowing the Henry's law. Now let us see the reaction, what happened exactly. Now whenever the Cl2 is the gas, whenever it allowed to pass in a water, then it becomes mixed with the water, so it is called the Cl2 aqueous. Once it dissolved, then the reactions occurred with sodium hypochlorite. Means whenever the Cl2 is the aqueous in presence of water, then the sodium hypochlorite is formed along with the removal of the chlorine and hydrogen. Now the hypochlorite acid is weak acid. We know that the hypochlorite acid is the weak acid that dissociate to form hypochlorite ion. Means that is the weak acid, so it can easily dissociate and it form the H plus ClO minus. So that whenever the hypochloric acid is get dissociate, then the kinetic of that reaction or the order of reaction is given that it dissociate into H plus and OCl minus. So, all forms of chlorine are measured as the milligram per liter of Cl2. So, that the molecular weight is the 2 into 35.45 is equal to the 70.9 gram per mole. The hypochlorous acid and hypochlorite ion compose what is called the free chlorine residual. These free chlorine compounds can react with many organic and inorganic compounds to form chlorinated compounds, means that free chlorine which are removed from the hypochlorite, then that again whenever reacts with many uh, organic and inorganic compound, then it again form the chlorinated compound, means the chlorine containing compounds. If the product of these reactions possess oxidizing potential, they are considered the combined chlorine residual. A common compound in drinking water system that reacts with chlorine to form a combined residual is ammonia. Means the common compound in drinking water system which are easily react with chlorine is the ammonia, which is form a residual to chlorine. Now the reaction between the ammonia and chlorine form the chloramine. That chloramine is mainly the monochloramine, means NH2Cl. Also it form the dichloramine like NHCl2 and trichloramine NCl3. We know that the nitrogen having 3 bonds, so that whenever we consider the monochloride, then means it is the NH2Cl. Whenever it considered as the dichloride, means there is again the one chlorine increase with removal of one hydrogen, and whenever the 3 chlorines are added or attached to that nitrogen atom, then all hydrogens are removed. It's called the trichloramine. For the drinking water utility, use the monochromoamine as a disinfectant. We keep in your mind that whenever we consider that the trichloro, monochloro and dichloramine, then in these three the monochloramine is used as a disinfectant for the water which are we use for the drinking purpose. If the excess free chlorine exists, once all the ammonia nitrogen has been converted to the monochloramine. Chloramine, the species as oxidized through what it is termed the breakpoint reactions. The overall reaction of the free chlorine and the nitrogen can be represented by the two simplified reactions. That reactions are like when the monochloramine formation reaction. We know that the monochloramine means the NH2Cl. This reaction occurs rapidly when the ammonia nitrogen is combined with a free chlorine up to the molar ratio 1:1. Means whenever we consider as the hypochlorite, we know that the H plus get removed with a OCl minus. That OCl minus again dissociate into single oxygen and Cl, then again forming the NH2Cl. This is called the monochloramine formation reaction. Now the breakpoint reaction. When the excess free chlorine is added beyond the 1:1 initial molar ratio, then the monochloramine is removed as follows. Like when the ammonium chloride, twice molecules of monochloramine reacted with hypochlorite or the hypochloric acid, then it gives the nascent nitrogen gas with hydrogen, then removal of chlorine in the presence of water. The formation of chloramine and the breakpoint reaction create a unique relationship between chlorine does and the amount and form a chlorine as illustrated as follows. Now the next concept is the chlorine demand. Free chlorine and chloramines readily react with a variety of compounds like including organic substances and inorganic substances like iron, manganese, etc. The stoichiometry of chlorine reaction with organic can be represented as follows. That stoichiometry means the balanced reaction, or the having a small equivalent of reactant and product. A ratio is balanced is called the stoichiometry. Now the hypochlorite, whenever the 1/10 of C5H7O7 O2N has reacted with hypochlorite, then it gives the 4/10 CO2 with 1/10 HCO3 minus plus 1/10 NH4 plus H plus Cl minus plus 1/10 of H2O. Now oxychloride, 1/10 of C5H7O2N whenever reacted with OCl minus, then it gives 4/10 of CO2 plus 1/10 of HCO3 minus plus 1/10 of NH4 plus Cl minus plus 1/10 of water molecule. Then the third one is the NH2Cl, 1/10 of C5H7O2N plus NH2Cl plus 9/10 H2O. It gives the 4/10 of CO2 plus 1/10 of HCO3 minus plus 11/10 of NH4 plus Cl minus. These are the chlorine demand reactions that can increase by oxidation reaction with inorganics such as the reduced iron at corrosion site at the pipe wall. The possible reaction with all forms of chlorine and iron are like follows. Now the next concept is the treatment plant layout and seating. The treatment plant layout is the arrangement of design treatment units on the selected site. That seating is the selection of the site for the treatment plant based on the future features as character, topography and shoreline. Development should take the advantage of the exciting site topography. The following principles are important to consider for the plant layout. First is the site on a side hill as facilitate gravity flow and will reduce the pumping requirement, and locate normal sequence of unit without excessive excavation or fill. When the landscaping is utilized, it should reflect the character of the surrounding area. The site development should alter existing naturally stabilized site contour and drainage as little as possible. The development site should be compatible with existing land use and the comprehensive development plan. These are the in general the short important which are considered, or the main principles or are important for the consideration of the plan site. Now the next is the treatment plant hydraulics. Hydraulic profile is the graphical representation of the hydraulic grade line through the treatment plant. The head loss computation are started in the direction of flow using water surface in the influent of the first treatment unit as the reference level. The total available head at the treatment plant is difference in water surface elevation. In the influence of first treatment unit and that of in the last treatment unit. If the total available head is less than the head loss through the plant, flow by gravity cannot be achieved. In such cases, the pumping is needed to raise the head so that the flow by the gravity can occur. In generally, there are many basic principles that must be considered by when preparing the hydraulic profile through the plant. Some are the include here, like first one is the hydraulic profile are prepared at the peak and average design flow and at minimum initial flow. Second is the hydraulic profile is generally prepared for all main path of flow through the plant. Third is the head loss through the treatment plant is the sum of head losses in the treatment unit and the connection, piping and now the last one is the head losses through the treatment unit include like head losses at the influent structure, head losses at the effluent structure, head losses through the unit and miscellaneous and free fall surface allowances. The last one is the total loss through the connecting pipings, channels and appurtenances is the like the head loss due to